everyone, my name is Pasha Finkelshteyn, I am from Russia and I work at JetBrains on Big Data Tools plugin. I have quite strange experience including development, data engineering and management, and I am going to speak about my experience with integrating Spark with Kotlin. I wanted to create API and I did it. Welcome! Hi everyone, my name is Pasha Finkelshteyn and I'm giving a talk Love to Frankenstein's Monster, Kotlin for Apache Spark. It will be a story of Kotlin and for Apache, but at first let's talk a bit about me. It will be a small Vanity Fair. I'm like 14 years in IT, I'm 11 years in development. Before development, I was working like system administrator, NK system support guy, and so on. In development, I have tried different roles as developer, as team lead, and even small CTO. So I have very, strange background of mixing anything in my career. I am almost 2 years in data engineering, and now I'm building tools for data engineers in JetBrains. Our main product for data engineer is called Big Data Tools, but this talk is unrelated to Big Data Tools. This talk is about Kotlin and my experience with it. To be honest, I am in love with Kotlin. I have tried my Kotlin first time at years before release, and my first time in production with Kotlin was few weeks before first release of Kotlin. But I already knew that it will be released, so it was quite stable. I was first adopter of Kotlin in Sberbank's production. Sberbank is the biggest bank in Russia. Its name is actually Sber now, but it changes nothing. I'm giving talks on Kotlin, and I'm trying hard to use it everywhere I can. For example, I'm trying to use it in data engineering, and this talk will be about Kotlin and data engineering. My career in data engineering is quite short, as you could see, but it could be complemented with my work as developer. Of course, data engineers usually work with Java, Python, and Scala. When we talk about Apache Spark, which is the topic of this talk, it's Scala as first choice, Python as second choice, and Java as a third choice. And of course, I started with Scala. It's native. Spark is written in Scala. I can write in Scala too. I can actually write in almost any JVM language and several more languages. But soon I realized that lots of things could be easier for Kotlin. I believe that most part of you don't know lots of things about Kotlin, so let me give you small examples, small hints about what is different in Kotlin from another JVM languages. First, it's null-aware and it has null save type system. It has extension methods, REFI generics, DSL building abilities, and it's quite compatible with other JVM ecosystem languages. For example, it's compatible with Java very good, like 99.9%, and it's quite compatible with Scala. We can call almost any code from Scala like 80% of code. Okay, most part of the code. So now let's dive into each of these parts separately to know about it. When I speak about null-aware type system, I mean following. For example, in Java, you have class object. In Scala, you have class any, and every other classes are derived from these classes. And Kotlin has such class too. It's called any. Then, of course, classes can inherit from one from another. For instance, on picture, you can see that another inherits from some. And also, there is spatial class, which is called nothing in Kotlin. which can't be instantiated in any way. You can't create nothing. So if it is declared that some method returns nothing, it actually can only throw exceptions. But contrary to Java and to Scala and to Groovy, there is parallel implicit type system, which is nullable type system. For example, any is inherited from any question mark. So if you can return any question mark, you can return any and not vice versa. And every other class can be derived from class with question mark at the end. And if we declare that we can return or use, like in method argument, type with question mark, it means then we can handle nulls there. Why is it important? Because null pointer exception is quite popular, and on the other hand, it is crucial to handle nulls correctly in Spark, and we'll use it a bit later. Okay, let's look at some examples. For example, we have some class Z, which is declared like class Z without even curly braces. It means there is no fields and no methods and nothing. So we declare two fields, null Z and Z. First of them may instantiate null because it's declared as Z question mark, and second can't be instantiated. Null can't be assigned to Z because it's not declared as nullable variable. So if we will try to print null Z is Z, we'll get false. Is Kotlin analog for instance of in Java or is instance of Scala? So you can see that nullable type is not instance of, not nullable type. But in all of the cases, nullable types are instances of nullable types. For example, Z is instance of Z question mark, big Z question mark. Okay, that's what I wanted to tell about nullable type system. Now let's talk about extension methods. We have alternative. We have analog for extension methods in Scala. It can be written in implicit class, but it's quite, verbose. It takes like 5 lines to declare extension method. In Kotlin, it may be much shorter. For example, imagine following situation: we wanted to sum all the elements of all the int elements of some iterable, so we can add extension method iterable int dot sum, and then in body of the method we can call a reduce, which I hope you are familiar with. Of course, function like this is already exists in standard library of Kotlin, like many more specific things for different types of collections, strings, and so on. Next interesting thing is reified generics. Thing is, you can't have reified generics in JVM ever. Java does not support reification. Java bytecode doesn't support reification. So in Scala, we can hack it some way. We can, write metadata in our class file about reified generic. It makes class files pretty hard to read and pretty big. But in Kotlin, we have another solution. In Kotlin, we have inline methods. What's inline method? Well, I believe that name of inline methods talks for itself, and it's being inlined into calling method. For example, if we have some function run it, which accepts another function returning unit. Unit is alternative to void in Java. Then this method will be fully inlined in the calling method. And if it is inlined, we can use reified generics there, and we have keyword reified for that because at the call side, we actually know that which classes do we use. And at this point, I should say that this talk will be pretty hardcore. It will be very JVM specific and Kotlin and Scala specific. There will be hard things which are hard to understand, which you don't know without hard to understand if you don't know JVM languages or you know only, for example, Python. But I hope it will be useful for you too, because Kotlin for Apache Spark has some benefits for you as Python developer too. And let's go further. DSL building. What is DSL? DSL is domain-specific language. It's language which can describe, some specific domain model. For example, on current slide, you can see that there is special, class HTML. It's not defined in this snippet, but it can be defined anywhere else. There is function HTML, which accepts function of HTML class or extension to HTML class and returns HTML. And then we can see extension method h1 for HTML, which accepts text and calls some method add element. For example, if our HTML has method or function add element, it will be called with text inlined into h1 text. And then we can build very simple DSL HTML h1 example, which is exactly type safe HTML. We can't insert in HTML nothing it doesn't support, if contrary to real HTML. And of course, it can be easily rendered to HTML, which is pretty useful. And JetBrains even have library called Kotlin HTML for this purpose, to build type-safe HTML. But my talk is not about it. My talk is about Kotlin for Apache Spark. And this is the place where our journey begins. Well, I mean, it's talk about Frankenstein, so it's where our journey to Frankenstein begins. Why Frankenstein and why monster? Of course, it's like my show name, so I just cannot joke. I just have right to joke about it. And actually, we need to crossbreed Kotlin and Scala to produce something with the best parts of both worlds. It means we can use null safety, for example, and extension methods to bring you better API for Spark. But at the beginning of experiment, we don't have any idea on its behavior. How should it look like? How should it work? I only had some abstract idea that I want Kotlin for Apache Spark to, solve problem of nullability and have nice API. That's all I had, basically all I had in my head. So my first goal was very simple. We can easily find code like this in Apache Spark, like we do in list. We are converting it to data set, then we are mapping it to first element, and then we are showing it. Result of this query will be 1 and 2. That's very simple. So my first sketch was like that. As I said, Kotlin is very compatible with all the JVM languages. So I just could call Spark session or create. Then I could create a list of. 2 is a function which creates converts pair of arguments into pairs. Nothing interesting here. Then I call some map function, which actually returns this pair. And I use encoder's bean. It is from function from Spark, which can encode any Java bean for you. And then I call shell, of course. And it fails. Well, it's first sketch. But I was pretty disappointed because, well, it should work. Why doesn't it work? It doesn't work because Kotlin pair doesn't conform to Java Bean specification. Java Bean specification declares that your class should have zero args constructor and getters and setters for all arguments. Of course, it is not the case for data class pair, because data classes are perfectly like Scala case classes. It's one constructor with several arguments and only getters, and of course equals hash code and so on, several supplementary functions. Of course, it won't work. Okay, but let's make it work at least with primitives, like let's convert list of integers to something and check if it will work. Luckily, there are primitive encoders in Spark. They're built into encoders class, so it has encoder for Boolean, byte, short int, and so on. So I can easily create map of these encoders, and encoders is the basic entity of Spark which can convert, serialize, and deserialize something we need. So for primitive classes, it started working immediately. I've created, like, I'm sorry, basic function encoder, which tried to find basic encoder for our class. If it found it, it have returned it, and then other way, it tried to use encoder's bean or encoder's cryo. And actually, it will work for Java beans. It will work for primitives, but it won't work for data classes. Why do we want it to work with data classes? Because we want to use idiomatic code for Spark. It uses case classes, and we want to have this too. So, but it starts to getting real. I'm sorry that 1, 2, 3 are barely visible on the slide. I'll fix it, but you can get an idea of how did it work. We had Spark, and we had some extension method 2ds, which accepted list of something and could show it, and it starts to look like Spark DSL. Basically, we can even say that Spark is DSL, or it's separate language or library. Okay, it doesn't matter, because our APIs starts to look like Spark. And our next question is type inference. As I've said, we want to use case classes or data classes in Kotlin, and they can be generic. For example, pair in Scala is generic, and pair in Kotlin is generic too. And generics are actually everywhere. I believe that you have something like result class in your own production code, which can contain, like status code, like exception message, and some other entity. Some other entity is our generic, of course. And these generics are being erased at runtime. We need to find some hack. Well, I have quite big background as Java developer, and I remember that in Jackson, the most popular library for serialization of JSON to JSON and from the JSON, there is some special class called type reference. It's abstract. It has field type, and it has some quite sophisticated logics inside it. You can instantiate it. For example, you can create a new type reference with inherited from this type reference. It's abstract class, so you have to inherit. And in constructor, that type, the real generic type, could be reified, because if you inherit from abstract class with concrete class, its signature, generic signature, its generic type will be written in your bytecode. So at runtime, you can get it from bytecode very easily. It's get actual type arguments at 0 index. And in case if you did something strange, for example, you have created some class with byte body or another instrumenting library, at runtime, there will be thrown illegal argument exception, but to be honest, I have never seen it to be thrown. Actually, it can't happen. Of course, there are ways, but nobody uses them. So let's try to port it to Kotlin, because Kotlin is quite compatible with Java. Very, very good compatible. It has like 99.9 compatibility, as I said. The code is straightforward. It's basically the same. So it should be easy. Init is our constructor block. So we get a generic superclass. We require our parameter to be class. Otherwise we will throw error. And then we set type to parameterize type. Actually, the same code. Let's compare. It's basically the same. And let's try to use it. It's some sophisticated code. I won't, dive deep into it, but basically it's we are trying to get row type from this parameterized type impl, and then we create some struct, and it won't work, which was really shocking. And I was a little bit scared at this moment, because I thought at a couple of days that I won't be able to solve this problem. If it doesn't work, what should even I do? Thing is, Jackson's hack won't work in Kotlin. And by the way, it's the beginning of the story of love to the monster, because when everything is easy, love won't happen. So what do programmers do when they don't know answers? They're going to Google and find, weirdest solutions. Please don't read this code. It's really awful and really hard to understand. It took me like hours to understand, and it's the whole story. And sponsor of the horror above is Alexander Udalov. Alexander Udalov wrote it when he was at JetBrains, and he was looking for a solution of the very same problem. By the way, he works at JetBrains, and that's quite good. Well, I've tried to use it. I have found some, bad behavior things. So I wrote to Kotlin chat searching for some better solutions. And guys, there actually Alexander Udalov found my message, and he told me, "Hey Pasha, there is type of function as of Kotlin 1.3. It's experimental, but it's really awesome. It's really awesome because it works in compile time." What does it mean that it's experimental? It means that it means that if you are going to use it in production, well, it will break. We don't know for sure, but you can be sure that it will work as example, or it will work at all, that it will work in all cases, and so on. But it's much faster than Scala's type text, because Scala's type text work at runtime and type of work at compile time, which is really awesome. So our schema inferring mechanism starts to work another way. It starts to work based on type of, which works really awesome. Or we can search for primitive schema and so on. Then if we don't know, if the class is not primitive, then we create some simple type wrapper, and we'll talk about them a little bit later. And of course, at the end of the day, we will find arguments of this generic. Also, we have special method which will relate names of generic arguments and their real types, and we'll merge them in one map. And this method is transitive merge. It's pretty simple. If you can see, this code is, by the way, is open source, so don't hesitate to contact me and ask me how this works if you need it. But basically, transitive merge just remembers in map generic signature to runtime time. For example, in pair, we have generic signatures A and B. And for example, the runtime types can be string and integer or anything else. And new inference starts to look like this. It's struct type. We can create struct type. What is struct type? It's basic thing from Spark, which describes any structure, object or object-like structure. For example, but there is similar things for maps, lists, and couple of other things. Okay, how does it work? We are trying to find primary constructor because data class as well as case class has only one constructor. Then the primary constructor could be and have to be defined. Then we get it parameters. For each parameter, we're trying to find in our map the real runtime type. Then we are creating property descriptor. It's something from Scala, from Spark, actually, descriptor of property, which says which runtime type, which type should be used in Spark to serialize this thing. And then we create case struct field, which is actually descriptor of field or handle of field, if you would like to use this term. So but you could see like several crutches here. For example, case struct field is wrapper of a struct field which holds information about runtime class and so on. Case simple type wrapper is wrapper for primitive types like integer, string, and so on, types that do not contain any fields which, at least I mean public fields. And data type wrapper is a wrapper of a data class. Data class, as I already said, is like case class in Scala. So this wrapper is called real classes, nullability information, and so on. Why do we need nullability? Because there are joins in Spark, and we want joins to be type safe. Then I have actually I've copied Scala serializers and the serializers from Spark to our project and rewritten them a bit, keeping in mind that Kotlin doesn't use spatial Scala classes, but on the other hand, we have information of nullability, and so on. So I've added new classes, serializer for and deserializer for, which accept Java class, and data type with class. Data type with class is actually Scala trait, which is parent of all those nasty wrappers, data type wrapper, map wrapper, and so on. Simple type wrapper, just because this, and actually information on nullability and on actual Java classes is held in this trait and inherently is held in child classes. Then, because I have my own predefined data type, if it is defined, then it means that this class was called from a Kotlin code, and I can infer all the things I need from there. For example, I can get real class from data type wrapper. You should understand that pair is not, self-contained. Pair can contain other pair, which can contain other pair, and so on. So it's a recursive algorithm. I will dive deeper and deeper until I'll find all the classes I need to know. So on each step of my recursion, I can find class, I can get properties from there, I can find struct fields from these properties, and so on and so on. And then Scala's create serializer for object to have my own serializer. Let's continue about dark sides of Scala. It took lots of debug because Scala is very type safe, and you can write very type safe things in Scala, but when it goes to code generation and Spark works on code generation, it's not this type safe. Basically, it's all the string inside another wrapper of the string, inside another wrapper on the string, and so on. So Kotlin is not type safe, and it means that you can put any expression inside any expression, and it will try to work, and it will fail at runtime, not at compile time, as we believe it should in Scala. So we can use, couple of instruments there. First, we can use log-level debug to be able to output the whole debug information about generated code, about execution plan, and so on. And we can turn on Spark SQL code comments. It's special property which will insert special comments into the generated code. Here I should say the thing or two about code generation in Spark. Basically, Spark generates lots of code. It's called Kotlin, obviously, and it works following way. It gets unsafe row as the input, then it processes it by the several stages. For example, if you have map and reduce, there will be 2 stages of processing your input row. It's deconstructed into some primitive-ish objects like UTF-8 string, text, and so on. Mutable objects, which is interesting. But generated code is not readable at all, because it has some weird internal names that are generated, and it's fine when you're a user of Spark. You actually don't need to know what code generates because it just works. But when you're trying to develop something, around Spark ecosystem, for example, get support for Kotlin language or anything else, you have to work with this code generation. It will be huge pain. So any comment will be useful, because comment says, okay, this unsafe row is a representation of data class la 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 la, which contains following fields. So please look at it and find your fields there. After quite a large amount of work, it became alive, which I was happy about, and currently it's released as Kotlin for Apache Spark 1.0 preview 1. Why is it preview 1? Because it supports only Spark 3.0. And Scala 2.12. We should support at least, I believe, Scala 2.11, because major distributions of Hadoop still work on this version of Scala. And we should support Spark 2.3 and 2.4. And this support is in progress. Actually, I have, I think, 2 or 3 issues to resolve before I can say that we support Scala 2.11 and Spark 2.3 and 2.4. Why should you even care? why should you try to use Kotlin for Apache Spark? Oh, that's quite easy. If you're a Python developer, then the Kotlin for Apache Spark API is the most simple entry point for you, because Kotlin is very simple language. DSLs are really fine. Auto-completion is ID, which is important, works really awesome, and JetBrains is committed to make it even better. We actually do it better if you are using Zeppelin notebooks. We have even code after completion in Spark SQL and raw data frames. Then, if you're a Java developer, there is much less clutter in your code. Your code won't be these variables anymore, because there will be now any encoders, specific encoders which you should define, and decoders and so on, serializers and deserializer, no corner cases, and it's like better Java. You can just use it and don't care what is underneath. And if you're a Scala developer and you're happy with Scala, then maybe you don't need Kotlin for Apache Spark, to be honest, because Scala is awesome language, it's very powerful. But if you think that you don't like implicit things and you would prefer things to be explicit, then it's the way to go. Kotlin really solves this trouble. You can try it. The detailed instructions is located at JetBrains GitHub, JetBrains/Kotlin Spark API. And I believe I've finished. Thank you very much. If you have any questions, you are welcome to post them in Slido or in Q&A or in Q&A corner. Thank you very much.